Hi, and welcome to the beginning of Chapter 5, which actually starts back in 0.6. We skipped this section way back when because it made more sense for us to cover it now rather than it did during our prerequisite chapter, because the skills in there we haven't used since that point, so it would make more sense to do it now. So what they are about is about exponents. Half of this chapter is exponents, the other half is logarithms, and then we put the two of them together. But we're just mostly looking at exponents, specifically radicals. Radicals are a type of exponent, and also the simplification of them. This is really what 0.6 was. So to simplify this radical, I actually imagine it as two separate problems. I've got the square root of 60 and the square root of x cubed. You can treat them separately like that. Now, what you want to do with each one is you want to break it up so that one thing is a perfect square and then the other thing is not. With exponents, it's really easy. You just drop it down one because even exponents are perfect squares. Even exponents are perfect squares. So then you say, okay, well, x squared times what is going to be x cubed? Well, x. Numbers are a little trickier to track that down. We want to do the same thing. We want to break it up into a perfect square and a non-perfect square. So I think, okay, well, what is a perfect square times another number to be 60? So we're looking at like 4, 9, 16, 25, things like that. The one that is going to work the best is going to be 4. As 4 times 15 equals 60. This one is a perfect square, and this one is not, and that's fine. Now we can square root this stuff. The square root of 4, well, that's just 4. The square root of x squared is just x. Then you always have a single square root, and you put the things that we couldn't square root. We couldn't square root the 15, and we couldn't square root the x. That easy. This one looks like it's more complicated, and it sort of is, but it's really just longer. We have now 4 problems to work with. We've got the square root of 125. We've got the square root of x to the 5. We've got the square root of 25. And we've got the square root of x cubed. So just like before, we want to break all of those up. Rationalizing denominators, we got this quick little note. Oh, Mel's here. If you've got a square root in the denominator, that's considered rude, and we want to get that thing out of there. So these are the things that we multiply. Really, if you've got a square root down there, you just multiply the whole denominator by that square root, unless there's addition and subtraction right here. If you got addition and subtraction, you need to multiply what's called the conjugate, which is the same as what was in the numerator. I'm sorry, it is the same as what was in the denominator, except instead of a minus, you got a plus, or instead of a plus, you've got a minus. So let's try it. I've got this 5 over 3 square roots of 15, and I want to get that square root of 15 out of the denominator. Easy peasy. Multiply the numerator and the denominator by the square root of 15. We end up with 5 square roots of 15 over 3 times 15. Hey, then we can do a little cancel. This 5 and that 15 are going to cancel each other, so we'll end up with just a 3. And we end up with the square root of 15 over 9. Simple. Let's get a little more crazy and look at one where there is a where we need to do the conjugate. So in order to get rid of that square root, just multiplying by the square root of 3 will not do it. That is not enough to get rid of it. What I need to do is I need to use the conjugate, which is the same as what was in the denominator, but I changed the sign of what was in the middle. Okay. Since we're doing that to the denominator, we need to do that to the numerator as well. This thing that I've written in blue next to the problem is really just a giant 1. It's a really gross one, but it really is just a giant 1. So all I'm doing in this step is multiplying by 1. That's it. So in the numerator, it's easy. You just distribute that thing in there. So you get 7 plus 7 square roots of 3. In the denominator, we need to FOIL. That is similar to a difference of squares problem because they match identically, except one's positive, one is negative. So all you have to do is square the first thing, square the second thing, slap a minus in the middle. Done. Well, not done. We got to simplify that a little bit more. If you want to FOIL that out, you can FOIL that all out to double check to make sure that works, but that is really all you'll end up doing. It'll square the first thing, square the second thing, slap a minus in the middle, because it's just difference of squares. That is difference of squares. So let's simplify. So the numerator is going to stay 7 plus 7 squared, so 3. In the denominator, that 1 squared is 1 minus 3. So we get 7 plus 7 square roots of 3 over negative 2. Woohoo! Simplified. Let's do another one. This one's going to be a little bit more complicated. Oh man, there's so many square roots, but it's going to be just as easy. Well, not just as easy. It's going to follow the same steps. I want to copy what's in that denominator, but I want to change that plus into a minus. I want to do the opposite of whatever sign is there. So now it's going to be square root of 2 minus the square root of 5. I have to do the same thing to the numerator. Done. Now, for that denominator, we got to do that same thing. We got to square the first one, square the second one. So we got square root of 2 squared, square the second thing, square root of 5 squared, slap a negative in the middle. Unfortunately, however, our numerator, not so nice. Those two don't match perfectly, but one is a plus, one is a minus. Sure, one's a plus, one is a minus, but the numbers are all mixed matched and all over the place. So we are going to have to FOIL that numerator. Sorry, it's just what we're going to have to do. So we get the square root of 14. Mel wants to help. She just meowed at me. So that's our first. Then we do our outsides. So that's minus the square root of 35. Can you help, Mel? And then we've got the square root of 2 times 3. Get out of here. Plus 3 square roots of 2. Plus 3 minus, minus 3 square roots of 5. Yeah, I think that's good. All I need to do now is simplify that denominator. So square root of 2 squared is 2 minus the square root of 5 squared, that's 5. My numerator isn't going to change, so I just need to copy that. There's nothing really in here that can simplify. The 14, we can break it up into a 2 and a 7. That's not going to do much. The 35, we could break up into a 5 and a 7. That's not going to do anything. So we're just going to leave it this big old mess, and that's fine. Same thing with our denominator, 2 minus 5. Well, not same thing. 2 minus 5, we get negative 3. That is fully simplified at this point. And so then numerator is square root of 14 minus square root of 35 plus 3 square root of 2 minus 3 square root of 5. There we go. That is simplified. Well, simplified in the sense that it doesn't have a square root in the denominator. So that's cool. All right. Next, there is a particular rule about exponents, the rational exponents rule, where if you have a radical, you can rewrite that as a fractional exponent. Also, fractional exponents can be rewritten as a radical. depending upon what you would like to do with it. So this 16, I know how to square 16, I know how to cube 16, but I don't know how to 3/2 16. So what I can do is I can convert this into the square root, or really there's no need to write that too, so I'll just write nothing. The square root of 16, and I can put the cubed here, or I can put the cubed on the outside. It doesn't matter where you end up putting it. So we squared that 16. I'm going to put it on the outside, the cube. I have to put it somewhere. Square root of 16, that's 4, and still cubed. Then I need to do 4 cubed, which is 64. Whoop, easy. Finally, we want to check our exponent simplification rules. Can we simplify this expression? So we have a 1/2 exponent that is outside. We need to distribute that to all of the different terms that are inside. I can do that right now because there's no addition and subtraction. So I can use the power rule to give that exponent to everyone in there. If there was addition and subtraction, I wouldn't be able to do this, and I'd have to do something else. Fortunately, we don't have that right now, so ace. So everybody in the numerator is going to get a 1/2 exponent. Everyone in the denominator is going to get a 1/3 exponent. And when I'm multiplying these fractions by their numbers, really that numerator just kind of becomes whatever I had before. So 2 times 1/3 is 2/3. 3 times 1/3, ooh, this one actually is a nice whole number. It's 1. Nice. Now I can simplify some of these numbers. 27 to the 1/3, that's the cubed root of 27. We just did that. It's 3. 16 to the 1/2, that's the square root of 16. We just did that. It's 4. The x's I can't do too much with, so I'm just going to leave those for a second. All right. Now, those rational exponents, we can subtract them just using our quotient rule. So we could do it before, we can still do it. So 3/2 minus 2/3. Let me do a little thought bubble here. I have to do 3/2 minus 2/3. I get common denominators between those two. So that's 9/6 minus 4/6. So that is 5/6. Whee! Then we do the y, same deal, but this one's a little bit easier. We got a 1/2 minus 1. I can do that one in my head. It's negative 1/2. Cat break! Cat break! Cat break! Now, one thing you might notice, though, is that since that's negative, that's going to go into the denominator. Ooh, well, shoot, I don't want exponents square roots, because that's what that is. I don't want square roots in my denominator. So let's not do that simplification. It worked okay with this one because that's going to end up in the numerator, but this one's going to end up in the denominator. So let's just not do any of that simplification. Let's not do the quotient rule because it causes a negative exponent. It causes a square root in the denominator. So we get 4 to the 5/6 over 3. And I'm going to go back to the y and the y squared, the ones that I had right here. We're going to go back to that. Because otherwise I would have had a y to the 1/2 in the denominator, and I don't want that. That's a square root in the denominator. Not okay. That's very rude. I don't want to do that. And that's about it. Before I go, I do want to call your attention to this. This is a collection of all of the exponent and logarithmic rules. You have seen all these rules before, but it would be a good idea to get practicing with all of these rules. There's a lot of things going on in this chapter, and if these rules cause you trouble keeping them straight and knowing when to do what, nothing's going to go well for you. Even knowing all of these rules, that doesn't guarantee everything's going to be fine. But you want to make sure that these rules are solid because that's the foundation of everything, but there's a lot that we're building on top of it. So these rules, I'm just taking as a given that you know how to do, but you might need some refresher. I've built a Quizlet online that you can check out. It may not be around the time of this video, but there is an online Quizlet that you can check out to see how this goes. And that's it. All right. Thanks for joining me and have a good day.